Welcome back everyone. In the last lecture we had seen what are state space equations, what are output equations, okay, and we also saw an example where we found out the state equations or output equations. Today we will take up two more examples and we will try to find out the state equation and output equation of those two cases. Let us dive in. Let us take this example of a spring mass damper system and we want to find out the state space equation for this. So, how do we find this? So, the first thing if you remember was that we need to identify what are the state vectors, what is the state vector, what is the input and what is the output. So, in this case as was pointed out in the last lecture itself, we will choose position and velocity as the state vectors. You can come up with some other state vector also, no problem, but in this case we will come up with, we will say that x and x dot are your state vectors. So, these become your state vectors, these become your state vectors, capital X I am using for the state vector. What is your input in this case? Your input in this case is force, and what is your output in this case? Your output in this case is displacement xt. Okay. So, these are our vectors. So, now let us try to write down the state equation. So, what will our state equations look like? Our state equations will be of the form x of t, x dot of t, d dt is equal to a matrix like this, then you will have x of t, x dot t plus a B matrix and then you will have input ut, and your output equation will be y of t, you will have a C matrix and then you will have x t, x dot t plus d of ut, right. This will be what we are looking for. So, let us try to write it down. So, d dt of x of t and x dot of t. Now, notice if I have to write it down. So, let us try to see what will be the first equation like. Okay. So, let us try to write down the first equation. So, what is the first equation? On left hand side you have x dot, right, because the first equation is d dt of x t, which is left hand side is x dot. So, if it is x dot, it is just 0 1, right, 0 times x t plus 1 times x dot plus 0 ut. This will be your first equation. Okay. Now, what is the second equation? In the second equation you have x double dot. Now, since we do not know what x double dot is, can I write down x double dot in terms of x and x dot? Let us see that. So, we know the differential equation of this system, right. What was the differential equation of this system? If you remember the differential equation of this system, I mean you can write down the free body diagram, it will look like m x double dot plus b x dot plus k x equal to f of t, right. And from here you can see that x of double dot can be written as minus k by m or capital M x of t minus b by capital M x dot of t plus 1 by capital M f of t. Okay. And see, once I know this, I can directly write down this equation. So, what is d dt of x dot, which is x double dot? X double dot equal to minus k by m x t. So, this becomes minus k by m x t plus minus b by m x dot. So, minus b by m x dot plus input is 1 by m f t. So, 1 by m, and what is this u? U is f t, right, because our input was f t. So, this is my state equation. What will be my output equation? My output equation is y of t. I know that I have taken my output to be x of x t. So, c x. So, this was your A, I have found out A, this was B, I have found out B. Now, I am trying to find out C and D. So, what is the output equation? Y t equal to x t. So, directly I can write it down, x, if I just write it down like this, f of t. So, this is nothing but 1 0 0, right. So, this becomes your C matrix. So, this is the state space model for this system. So, this is how you can come up with the state space model for different systems. Okay, you will have to practice a bit to come up with the state space model. Let us try the example of the quadrotor that we had been talking about, right. If you remember, the transfer function was z(s) by as equal to 1 by s square in this case. What was the input in this case? What was the input? If you remember, the input was acceleration, right. We took acceleration as our input. So, a of t is our input. What is the output in this case? The output was zs, right, or z of t, right. Look at the transfer function, output by input, right. Z is the altitude along the z direction. Then what is the state vector now? What will be the state vector? So, this is the question that now needs to be answered. So, the first thing is that this is a second order system. We have found out the transfer function 1 by s square. So, what will be the differential equation here? Z double dot t equal to a t, right. Go back to the lecture there when we talked about this. So, in this case z double dot t equal to a t is your differential equation, and in this case what can be the state vectors? Now, you see, in this case we know that there will be two state vectors because it is a second order differential equation. So, two state vectors. What can we choose? We can choose one of the state vectors to be position and the other to be velocity. Okay. So, if velocity and positions are the state vectors, so then zt and z dot t are your state vectors in this case, right. So, now let us try to write down the state equations. So, d dt of z of t, z dot of t must be equal to ax. So, now what will be the dimension of A? So, the dimension of A will be 2 cross 2 because there are n is equal to 2 here, the number of states are 2, right. So, this is a 2 cross 2 matrix. What will be the dimension of B? Because there is one input, acceleration is the input. So, this is a single input system. So, n cross 1, so 2 cross 1, right. So, 2 cross 1, B will be 2 cross 1, input is A of t. Okay. Let us write down the state equation. So, what is the first equation? Z dot is nothing but 0 1 0, right, because left hand side is z dot, right hand side 0 times zt plus 1 times z dot plus 0 plus at. So, this is the first equation. What is the second equation? The second equation is z double dot. So, this is nothing but, notice that this is nothing but z dot and z double dot, right. So, what is z double dot? Z double dot is at, right. So, that means none of the state variables will come in and 1 will be here. So, this becomes your state equation. Okay. So, this becomes your state equation. Now, what is the output equation? What is the output? Output is zt here. So, output y of t is nothing but cx plus du. So, du is this. So, we have z as the output. So, 1 0 and 0 here. So, this becomes your state equation and output equation. So, for a quadrotor, this will be your state space model for the quadrotor when the quadrotor is moving along the z direction and we have taken acceleration as an input. Now, you see, we have seen two types of modeling, right. One was transfer function and one we have seen as state space models, like we took 3 examples now. Now, are these two types of modeling related somehow? Can I take the transfer function of a matrix and get the state space representation of the system, or can I take a state space representation of the system and get the transfer function of a matrix? It turns out the answer is yes. Okay, we can do that, and that is what we are going to look in the next lecture. Thank you.